Hi everyone, welcome again to discuss most important topic in mathematics, that is logarithms. Most of the students are feeling difficult using the technique of logarithms. So I decided to make a video on this and I will continue the videos on this as part 1, part 2, part 3 and so on. The logarithms, the technique of logarithms was introduced by John Napier. This is the name. John Napier introduced the technique of logarithms. What are the uses of logarithms? By using logarithms, there are more uses. With the technique of logarithms, difficult multiplications can be converted into simple additions. Similarly, confused or hard divisions converted into simple subtractions. These are very useful, particularly in physics, chemistry and other subjects also. When you are doing practicals in physics, you have to calculate, you have to find the value of difficult divisions, difficult multiplications, very small number, very big number multiplications. At that time, this technique is very useful. So you have to know the concept of logarithms and how to solve the problems related to logarithms. Before going deep into logarithms, you have to know what is meant by exponential form. From the exponential form, you develop the technique of logarithm. Suppose if I take 64 can be written as 64 power 1. Similarly, by changing the base, I will write 8 square also. If you change again the base, you can write 4 cube also. In these all three cases, the value of these is same. 64 power 1 is 64, 8 square is 64, 4 cube is also 64. Here 4 is called the base and this 3 is called exponent or power or index, whatever it may be here. Here base is 2, base is 8, index is 2. Similarly here base is 64, the power or exponent is 1. This way of expressing a number is called exponential form. This is called exponential form. Now we will convert the exponential forms into logarithmic forms. How it will be? We will learn after the definition of logarithm. Logarithms are defined only for positive values. So the logarithm of any positive number is defined as the index or power of base on which it is raised to get that number. The definition may confuse you, but I will explain you by taking some example. See, 64 is obtained by taking a base called 64, raising the base to power 1. And here I am writing 64 by taking base as 8, and to get this 64 I am raising an exponent 2 on 8. Similarly, by taking base 4, I am raising exponent 3 on 4 to get this 64. This power or exponent I raised on particular base to get these 64 is called logarithm. Suppose I am taking 4 can be written as 2 square and also the same 4 can be written as. Logarithm is nothing but power. Keep in your mind. Logarithm is power on which you are rising on a particular base to get the number. So logarithm of 4 can be written as log. Instead of writing full form of logarithm, I will write log. We will write for our convenience log 4. Okay, and the base in the exponential form is written here. To get these 4, I am I have to raise some power on 2 to get this 4. What is that power? 2. So that is the logarithm of 4 to the base 2. You will read it as log 4 base 2. Similarly, by changing the base, I will find log 4 base 4. To get this value, I am taking 4 as my base. To get this 4, I have to raise 1 here. That one is the logarithm of 4. Coming to this, log 64 base 64. To get 64, I have to raise 1 on the base 64. That raising, that power on 64 is the logarithm of 64. Here is 1. If you take log 64 base 8, when you want to get this 64, this base is raised to 2, then you will get 64. But this should not be written here. That is the value of 64 log 64 base 8. If you take another one, log 64 base 4, again this base is 4. To get 64, what is the power to be written on 4 to get 64? You know 3. That is the logarithm of 64 base 4 is 3. So it is appearing now easy. So logarithm of any positive number is the power or index you are raising on the base to get that number. That is the logarithm of that particular number. If you want to generalize it, you may write this is the exponential form. Then log b base a is equals to x. This is the way how to convert exponential form into logarithmic form. Very simple. Whatever the base in the exponential form, that will become again base here in the logarithm also. You are going to find the logarithm of this number b. So I am writing here whatever the power, that is the log. So is equals to x, which is x here. I am writing some numbers again to have better understanding. So 5 square is equals to 25. This is the exponential form. If you want to write this in logarithmic form, you know the power is the log of that 25. I am writing log 25. Whatever the base in the exponential form, that will become base here also, that is equals to 2. So log 25 base 5 is equals to 2. In this way, you may convert any exponential form into logarithmic form. I will take some examples, then it will become very clear. Okay. Before going into solve the examples, I want to have deep discussion on the base of a logarithm. When I am defining logarithm, I didn't say particularly about the base. Why? Because to have relieving from the confusion, I didn't mention particularly about the base. Now coming to the base. Why? Because you understand what is meant by a logarithm. Base of a logarithm is always greater than 0. It should be always greater than 0, but not equals to 1. So base of log is greater than 0 and should not be equals to 1. So now logarithm of any positive number to the base greater than 0 and not equals to 1 is the power or index you are raising on the base, is the logarithm of that particular positive number. I have taken some examples to clear the concept of logarithms very clear. Convert the following logs to exponential form. If you see the first one, what it says, log x base 81 is equals to 3 by 2. See, this 3 by 2 is nothing but power. to get this x on the base 81. Okay, therefore the first one will become x value is equals to 81 power 3 by 2. If you simplify it, you will get value of x. See, 81 can be written as 9 square whole power 3 by 2. 2 cancel, that is 9 cube. X value is 9 cube. You can convert this into exponential form and you can find the value of x. Here the second problem, value of log 243 base 9. I am writing here b. If you don't know its value, let its value be x. After assuming its value as x, convert it into exponential form. Then 243, how 243 is obtained? When you are raising this base 9 to the power x, right or not? So 243 is equals to 9 power x. So to find the value of this x, try to get same bases on both sides of the equality, right? 243 can be written as 3 power 5 and similarly 9 is 3 square whole power x. 3 power 5 is equals to 3 power 2x a power m whole power n. So on both sides you have same bases. So you have to equalize the exponents also. 2x is equals to 5, that implies to x is equals to 5 by 2. So by converting into exponential form, you can find the value of this logarithm. Therefore, you calculated x value, so you can write it as 5 by 2. Similarly, see, log 32 base 2. I will write here. Okay, this is c. Log 32 base 2. Similarly, you don't know the value of that, therefore assume its value as x. Okay, then if you convert it into exponential form, so 32 is obtained. How it will be obtained? When you are raising 2 to the power x, therefore 2 to the power x. Now I will write 32 by using my base 2. 2 power 5 is equals to 2 power x, therefore x is equals to 5. So it is very easy. In all cases your base must be greater than 0 and not equals to 1. Coming to the second one, if you see, convert to the logarithmic form. Very simple. 81 power 1 by 4 is equal to 3. This is the exponential form. Now I want to log 3 value to the base 81. So base is raised to some power to get 3. What is that power? That is 1 by 4. So log 3 base 81 is equals to 1 by 4. Similarly, in this case, log 1 base 7 is equals to 0. From this, you may conclude that logarithm of 1 to any base. If you take 7, your answer is 0. If you take 8, why? Because even if you take 8 here, 8 power 0 will become 1. That 0 is your answer. 10 power 0 is 1. So except 0 power 0, any number raised to 0 is 1. That's why logarithm of 1 to any base is 0. Keep in your mind. Similarly, if you take C, log 45 is equals to log 45 base 45 is equals to 1. In this case also you can conclude one thing. Logarithm of any number to the base itself. Okay, that is answer 1. Log 25 base 25 is 1. Log 20 base 20 is 1. So logarithm of any number to the base itself is equals to 1. So in this way you can define logarithms, and if you solve more and more problems, they will become very clear to you. So I hope you liked my video. If you like, don't forget to subscribe. Encourage me to do more videos on the important topics which are very useful to the students.